Welcome. Today we will look at the general topic of learning to code. Where to begin? One of the questions I am often asked is, where can you learn to code? How do you start off on the journey to be a programmer? There have been thousands of programming languages over the years, many of which are still going in one form or another. So how can you pick one to study? Well, there are a number of free and paid-for online resources that will provide guided and interactive training in a range of popular programming languages. Just open your favourite search engine and type "Learn how to code." Learning to code is like learning to speak a foreign language. It takes time and lots of practice to get really good at it. Someone once said to me that coding was just pressing buttons on the keyboard. Of course, they have to be the right buttons, pressed in the right order, at the right time. On the bright side, at least all the buttons have something written on them to say what they do, unlike musical keyboards. Coding would be so much harder if you had to memorize what all the buttons were. You may pick up some of the basics fairly quickly, but expect it to take about 3 months before you get comfortable enough to start creating your own projects from scratch. That doesn't mean you can follow guided tasks and start to tinker with code others have written. You won't be fluent in that first programming language, but you can get by and you will have built a solid foundation to take the study of that language and other languages further. Another question I am often asked is, how long does it take to master a language? In this, I'm very much of the "there is no mastery, there is only more practice" school of thought. As in the pursuit of any skill, it is a continuous journey of improvement, rather than a final destination. It has been said that it takes about 10,000 hours of practice to become an expert at something. This does sound like a lot, but if it's your day job, it works out at about 5 years. So let's assume that you have identified one or more online resources that can assist your learning. Which programming language or system should you learn? Perhaps we should look at the types of programming languages available. Is your interest in phone applications that you can publish and have people download? Perhaps you want to try your hand at web applications to create and run websites. Maybe desktop applications are more your thing. Even within these, you can have game development, corporate-type software, and utilities that are useful to anyone. Or maybe you would like to learn some type of query tool to allow you to interrogate and report on data within databases. There are also a number of Software as a Service systems, SaaS, that provide the structure of a full system but still allow them to be customized with embedded code. Don't be surprised if you find yourself jumping from one to the other until you find something that piques your interest. There is also the question of employment. Are you interested in programming in order to be employed as a programmer, or is it going to be a hobby? There is nothing wrong with hobbies, but if you seek employment, it's good to learn to program in something that employers are looking for. So you'll need to do some research here. Do you pick a programming language that is currently hugely popular, that has countless people learning it? Or go for something that is newer and less widely adopted, but could be the next big thing and there would be less competition for jobs in that field? So having looked to see what to code in, what comes next? Coding in isolation can be done, but if you're going to be programming professionally, you can expect to work as part of a team. So getting together with others to practice teamwork on a project of your own will be good practice. Bouncing ideas off other team members is a good way to get the best from the collective team members' skills and experience. As a professional programmer, you can expect that a lot of the requests for you to program won't originate from yourself. The originator of the request is likely to come from your user community, or from those heading up the company you work for. It is likely that some problem has emerged either with the functionality of an existing application or system, or something new needs to be added, or something is needed to integrate two systems together. In such cases, it's more than possible that the code you are to amend or extend was not written by yourself, and you will have to rely on both the documentation of the system and your ability to analyze requirements and problems. Being a programmer isn't just about having the ability to code. It's also advantageous to be a documenter and analyst too. Let's take documentation first. Traditionally, documentation is not a coder's favourite task. However, it is an essential activity to allow code to be maintained. Documentation can be formed from comments within the code itself, as well as external documentation, including diagrams and flowcharts. Much of the code you will be required to amend will have been written by someone else, possibly months or years earlier. There is a school of thought that code should be self-documenting. After all, if you can write code, you should also be able to read it. While this is true, and you can see what the code is doing, it may not be obvious why it is doing it. The company you end up working for may well have a coding standard, which includes naming conventions for what appears in the code. Let's take, for example, this line of code. A equals 6 plus B. This means nothing, as both of these variables give no indication as to their purpose, and the addition also lacks detail of why it is being done. To understand what is going on here, a programmer would have to delve into what preceded and followed this line of code to try and determine its function. The original coder may no longer work for the company, so you won't be able to pick their brains as to how the code works. So you'll have to rely on what documentation currently exists. In the event that you will be amending code that was written by yourself, it could have been written months ago, or even longer. So be kind to yourself and your colleagues and document your work. The programmer as analyst. In many large organizations, there is a role called business analyst, whose task is to listen to users, determine what they want or need, and then write a requirement. This set of requirements can then be passed to you, the programmer, to come up with a coding solution to what is required. However, even in large organizations, business analysts can be thin on the ground at times. So you may well find yourself doubling up as an analyst to bridge the gap between what the user would like and what you can actually deliver. Users are generally not programmers or coders or even analysts, and don't have the skills or inclination to think about how applications or systems work internally. So their first approach to you will be communicated in terms and processes they do understand. Like, for example, our data is in a spreadsheet, and we need it processed and saved to another spreadsheet. As a programmer and analyst, you may realize that a spreadsheet could be a cumbersome storage medium for the amount of data that they are now dealing with, and that a database may be a better choice. Teasing out what they need to see and amend within the data can be a time-consuming process. However, once this information is available, then it will be easier to create a new process that is more scalable, less error-prone, and easier to use than the current system. Your coding portfolio. Like a photographer or artist, you will, over time, want to build up a portfolio of projects that you have worked on and document your achievements. This can then be used to impress any potential employer as to your skills and what you could bring to their organisation. Some of these projects and code may well be in the open source community, where you have contributed to both small and larger projects. Such code is often held in online code repositories like GitHub. So it is well worth having a look at such open source code repositories to gain insight into what is out there in the wild. Being a programmer is a journey of continuous learning, as there are always new technologies and techniques coming along from which you can learn. You just have to take that first step. Hopefully, you'll find this guidance useful in your career as a programmer. But that's it for today. Thank you for watching.